Okay, so we're now looking at question number 5 from the January 2024 paper for Decision Maths. In here, we're given a graph with a feasible region, the vertices, the objective line is drawn, so pretty much everything is done for us in this question, but they want us to find the value of k when p is minimized. So when p is maximized, we have the value of p is going to be 540. So we want to figure out which points from these four vertices that we're given here, D, which is, why is it not hiding? Okay, so D, which is at 518, C 922, B is at 13 and 12, and A is at 6 and 8. So to find the vertices that we need is we're going to take this objective line over here, we're going to take it and we want to slide it across so we can find the minimum and the maximum point. So the minimum point is going to be the vertex which intersects with the objective line as we enter the region. So that's going to be vertex A. So we're going to need A, and also we're going to need the vertex C, because that's the one that's going to leave the region R as we as we slide the objective line. So that's going to be 9 and 22. So let me just write down the coordinates here. This is going to be 6 and 8, and this one is going to be 9 and 22. We don't need B or D for anything, so let's continue reading the question. It says an objective line has been okay when the objective function P is maximized, the value of P is equal to 540. And when the value of the when the objective function P is minimized, the value of P is going to be equal to K. So they want to find the value of K at when P is minimized. So let's just form an equation for this real quick. So when P min, we want to find the value at which we want to find the value of K for which P minimum occurs. So we know that P minimum happens at A, which has the values 6 and 8, I believe. Yep, 6 and 8. And we can assume, the question says you can assume that the objective function P takes the form AX plus P plus BY. So I can say that P min equal K, which is equal to AX plus BY. So let's just leave this on the side right now and let's work with what we are given. So the question says when P is maximized, so we know that happens at C, and the value that's going to be, and the value for P and the value for P is going to be 540. So let's just write this down. So at P max, it's going to be equal to 540. And that's going to be at C, which has coordinates, I don't remember, 9 and 22. Yep, 9 and 22. So we can say that this is equal to 540 is equal to AX, or not AX, A9A plus 22B. Now we're going to label this as our first equation. Now for the second equation, we can take a look at the objective line that we are given here, and we can actually find the gradient for this, and we can make out an equation from this in terms of x and y as well. So if we take a look here, we notice that we can use rise over run to find the gradient. So for every 4.5 blocks the objective line moves, it's going to go down by 4, so that's a negative gradient. So we can say, since we know that the objective line is equal to AX plus BY, we know that the gradient is equal to negative A over B, which is also 4 over 4.5, should be minus. So we can cross multiply this out, and when we simplify it, we're going to get 9A is equal to 8B. So now this is our second equation, and we can plug this inside our first equation. So from 2 sub in 1, so that's going to be 540 equal 9A. We already know that 9A is equal to 8B, so we can sub that in. So that's going to be 8b plus 22b. So we're going to get that b is equal to 540 over 30, and that the value of b is equal to 19. I'm sorry, value of b is equal to 18. Now we can sub this 18 inside the second equation. So we could say that a is equal to 8 into 18 divided by 9. And that's basically 8 times 2. So that means a is equal to 16. Now we can sub this inside our objective function, which was p equal ax plus by. Or actually, we can sub this inside our p minimum. Not sure why I was doing that. So p min, which we already found before, k is equal to ax plus by. We already found the values of x and b, a and b, and we are given the values of x and y. So we can say that k, so p min is equal to 16 into 6 plus b, which was 18 into 8. So we're going to get that p min equal to 140. So k equal to 40. And this is it for question number 5 from the January 2024 paper. And you can go on to the next question.